Normalisation. This presentation will cover what normalisation is and why it is used, the rules for first, second and third normal form, unnormalised data, how to normalise a database, advantages and disadvantages of normalisation. So what is normalisation? The purpose of normalisation is to identify a suitable set of relations that will support the data requirements of an enterprise. Characteristics of a suitable set of relations include minimal amount of attributes necessary to support the data requirements of the enterprise. Attributes with a close logical relationship or functional dependency are found in the same relation. And minimal redundancy. Each attribute should be represented only once. An exception to this are attributes that form part or all of a foreign key needed to join related relations. Desired characteristics of a database include it having efficient storage and being easy to maintain. Efficient storage means redundant data should be avoided. Easy maintenance means that a good design will logically separate data into tables. Normalisation is a design method that can be used to achieve this. Normalisation provides rules that organise the data efficiently, eliminate redundant data, and ensures that only related data is stored in a table. To aid the process of organising the tables into their most efficient states, 3 separate normal forms were developed. These are first normal form, second normal form, and third normal form. However, before a table reaches any of the normal forms, it is said to be in zero normal form. That is, it does not conform to any of the normal form rules and would be extremely inefficient. Examples of this are repeated data, the telephone field is repeated, and non-atomic data. This phrase non-atomic data will be explained later in this presentation. For the database to be in first normal form, the following rules have to be met for each table in the database. Each item cannot be broken down any further, it's atomic. There are no columns with repeated or similar data. Each row is unique, that is, it has a primary key, and each field has a unique name. Atomic is the word used to describe a data item that cannot be broken down any further. Examples of atomic data include an ID number, a national insurance number, an ISBN book reference, stock code, a first name, a surname, a telephone number, a school name, or a complete description. The point of the last 2 examples indicate that atomic does not mean just a single word. It simply means that it would make no sense to reduce the data item any further, as it would lose its meaning. Examples of non-atomic data are a full name, a full address, data that are part of a larger data set, for example Oxford Book Club. In this last example, the database in question is storing club details, and there are many different types of clubs, elf, book, chess and so on, being stored. So it makes sense to split this data into location club type. Oxford will be in the location table and book will be in the club type table. Therefore, the context of the database needs to be understood when deciding if data is atomic or not. Example of repeating data. In this case, the database is trying to store contact telephone numbers for each person. The designer has created 3 fields to hold telephone numbers. Telephone 1, telephone 2 and telephone 3. This is what is meant by repeating data. The telephone numbers are the same kind of data. Are these tables in first normal form? Have a look at this table, paying particular attention to the field names and the data held in each field. This is not in first normal form. There is no primary key defined, and so this record cannot be guaranteed to be unique. Also, first name is redundant. Data is not atomic, as it is simply a combination of first name and surname. This example is at least first normal form. It has a primary key identified by the underline. The data is atomic. Each field has a unique name and there is no repeat data. What about this example? Again, this is not in first normal form. Although it has the primary key, so passes that test. The data is atomic. It has been broken down as far as it can be. But the colour the shoe can come in is being repeated. And furthermore, the fields have the same name. So it is not in first normal form. Yes, this is in first normal form as it meets all the rules for first normal form. It has its primary key. The data is atomic. Name is split into first name and surname. All the field names are unique, and there is no repeated data. In second normal form, most tables tend to have a single attribute that is simple primary key. But sometimes a table has a primary key made up of more than one attribute. That is, it has a compound or composite primary key. The table above is using both the venue and the artist as the composite key. It is in this situation that the extra rule for second normal form comes in handy. The rule states, non-key attributes must depend on every part of the primary key, and the table must already be in first normal form. The concert example is not in second normal form. Notice this attribute called style. This is describing the style of the artist. It has nothing to do with where the concert takes place. And so its value does not depend on every part of the primary key. So the rule for second normal form is not being met. The reason for this rule is to ensure that no redundant data is being stored. For example, let's add another Girls Aloud concert to the table. Notice that the girl band value is being repeated, and so is causing the database to be bigger than it needs to be. Looking at the concert table, this table needs to be split so that non-dependent attributes are removed and only stored once. In this case, a style 2 table is formed that has artist as the simple primary key. Now the rule for second normal form is being met by both tables, i.e. every non-key attribute is depending on the complete primary key. There is no redundant data. For a database to be in third normal form, the following rules have to be met. It is already in second normal form. There are no non-key attributes that depend on another non-key attribute. What this is trying to do is spot yet another source of redundant data. If the value of an attribute can be obtained by simply making use of another attribute in the table, then it does not need to be there. Loading that attribute into another table and linking to it will make the database smaller. To clarify this, consider the concert table below. Notice that country could be attained by referring to the city. If the concert was in London, then you know that it is also in the UK. No need to look at the primary key. So to make this database into third normal form, split the table as follows. The new table called countries has city as the primary key and country as an attribute. The concert table has city as a foreign key, indicated by the asterisk. So now you can obtain the country in which a particular concert took place, and there is no redundant data. The database does not contain redundant data. It is smaller in size, so less money needs to be spent in storage. Because there is less data to search through, it is much faster to run a query. Because there is no data duplication, there is better data integrity and less risks of mistakes. As there is no data duplication, there is less chance of storing 2 or more different copies of the data. And one change can be made which can instantly be cascaded across any related records. There are, of course, problems with normalization. You need to be careful when trying to make data atomic. Just because you can split some tables of data further, it isn't always necessarily the correct thing to do. For example, the telephone number may contain the code followed by the number. It wouldn't be sensible to separate out these two items. You can end up with more tables than a non-normalized database. The more tables and the more complex the database, the slower queries can be to run. It is necessary to assign more relationships to interact with a larger number of tables. And with more tables, setting up queries can become more complex.